Hello, Matthews, Gatos here. Welcome to section 7.5, inverse trig functions. I'm going to do this over 3 videos, one for sine, one for cosine, one for tangent. Let's get started with sine. Now, sine of x, you have to remember your graph of sine of x. I have 2 cycles there from negative 2 pi to 2 pi. It has a range from negative 1 to 1. What we know about sine right now is that it's a function. So if I were to take this vertical line and slide it across my function, it only touches once, which means it is a function. However, if I take a horizontal line, I'm touching it in multiple points, so I can say that the inverse is not a function. So sine is a function, but the inverse is not a function. Now, we like to work with functions, so we need to restrict the domain in such a way that I force it to be a function. Now, when I talk about inverse of sine, I usually use sine inverse, the sine inverse notation there, but I want you to recognize that arc sine also means inverse. They mean the same thing. So let's go back to our sine graph. Let's restrict the domain to make the function an inverse. Now, I can restrict it in a couple of different ways, but I want to restrict it so that I have the most or the biggest piece of the graph so that I can focus on that to make it an inverse. So because I only want to touch my line, my graph once with the horizontal line, I'm going to restrict it from a min to a max. So I'm going to restrict it from this min to this max. So I'm going to look at just this piece of the original function. Now, if I take that horizontal line, just focus on the black part of the graph, and I slide it along, now I'm only touching it one time. So we're going to restrict the domain in the simplest way possible, which is from negative pi over 2 to positive pi over 2. You're going to need to remember that. So let's go ahead and look at the graph of what the inverse will look like. Okay, so here is my graph of sine x, and I've restricted it from negative pi over 2 to positive pi over 2. Okay, so here is my graph and my table of values for sine x, and I'm doing this in radians. Now, instead of dealing with pi's over 2s and pi's over 3s, I'm going to deal with numbers to the 10th. These are all radians, just so I can kind of visualize where everything is. Now, remember when we do domain and range of a function, it then becomes the domain and range is flipped for the inverse. So if I'm looking at arc sine or sine inverse here, the domain from negative pi over 2 to pi over 2 is going to become the range. So negative pi over 2 to positive pi over 2. The domain of the inverse is the range of the original function. So from negative 1 to positive 1. And I'll put on some square brackets there to show it includes it. Okay, so now let's look at our table of values, and we're going to flip everything around. So I'm going to take this point, negative 1.6 and 1, and flip the x and y values around. So negative 0.8 and negative 0.7, flip those around as well. 0 and 0, well, that's an invariant point, stays the same. 0.8 and 0.7 flips around. And 1.6 and 1 also flips around. So that's the definition of an inverse. So let's approximately graph that. So my scale, I'm going up by 0.8. So if I want to graph my first one, I'm at negative 1 and negative 1.6. So negative 1 just a little bit past here, and then negative 1.6. I am going to be, I don't know, approximately, we'll say down here. Okay, and then I have negative 0.7 and negative 0.8, so negative 0.7 and negative 0.8, maybe like right about there, and then 0 and 0. I'll have 0.7 and 0.8, so there, and then 1 and 1.6, so maybe there. Okay, so if I were to connect those dots, I'm going to have something that curves up and then like that. So that would be the inverse. So this would be arc sine or sine inverse of x. That would be what the inverse looks like. Okay, so we can see what the graph of the inverse looks like with that restricted domain. So let's use this idea of restricted domain to answer some questions. Okay, so for my first one here, I want to find the exact value of the following. So I want to find sine inverse of root 3 over 2. So basically that's saying is what angle would have a sine that was root 3 over 2. So we're going backwards, okay? So I know that on the unit circle, sine of pi over 3 is root 3 over 2. But I want to look for all of the angles within negative pi over 2 and positive pi over 2. So if I look at my cast rule, I'm talking about 0 to positive pi over 2 and then 0 to negative pi over 2. So I'm just looking at those two quadrants there. So quadrant 1 and quadrant 2. Now, since sine is positive, it only can be in quadrant number 1 because we know sine is negative in quadrant number 4. So that means that the sine inverse of root 3 over 2 is just simply pi over 3. Okay, let's try another example. So just so you're totally clear what that means that the point root 3 over 2 and the point pi over 3, sorry, let me say that again. Root 3 over 2 and pi over 3 is a point that is on y equals to sine inverse of x. Okay, let's try another one. So I want to know the sine inverse of negative a half. So let's see what we know about a half. So where is sine a half? Well, on the unit circle, the point on the unit circle pi over 6 is root 3 over 2 and a half. And there, that would be sine. However, they do want negative. So remember when we're doing sine inverse, we're restricting it from negative pi over 2 to pi over 2. So that's going to be here or here. And using our cast rule again, we're looking for where sine is negative, and sine is negative right there. So I'm going to take that pi over 6 reference angle, put it into quadrant 4, but it's going to be as a negative value. So that means that sine inverse of negative a half is negative pi over 6. So again, what that means is that the point negative 1/2 and negative pi over 6 is on a function y equals arc sine or sine inverse of x. Okay, let's up the fun factor with these questions. Okay, so let's try something like this. I want to do sine inverse of sine of pi over 4. So I have a little hint there for you, and I say work inside out. Work inside the brackets first, and then go from there. So sine of pi over 4. Okay, let's look at pi over 4 on the unit circle. We know that that is root 2 over 2 and root 2 over 2. So remember that we're restricting our domain to be from negative pi over 2 to pi over 2. Keep that in mind as we're doing. Now, pi over 4 falls within that range. And I know that sine of pi over 4 is right there, root 2 over 2. So this is really saying that I'm going to do sine inverse of root 2 over 2. So remember, sine inverse is going backwards. I'm giving you the ratio. You're going backwards to find the angle within the restriction of negative pi over 2 to pi over 2. So again, I always like to draw that out. So there's pi over 2 to negative pi over 2. Sine inverse of a positive ratio. So looking at my cast rule, I'm looking for positive ratio, so it has to be here. So the only angle in quadrant 1 that the sine inverse of root 2 over 2 would line up with is pi over 4. Now notice what happens. Sine inverse of sine, well, sine inverse and sine are inverse operations, so they in fact cancel each other out. But we have to be really careful just canceling them out and saying it's pi over 4, because we have to make sure it meets the restriction. Okay, so let's look at another example. Sine of sine inverse of negative a half. So we're working inside out. So first thing I want to do is I want to find out what the sine inverse of negative a half is. So I'm given the ratio, I want to go backwards to find the angle. So let's think what reference angle has a sine value of a half, and that would be the point on the unit circle pi over 6. So I know that's root 3 over 2 and a half. So there's my reference angle for sine. Now let's go into our cast rule, and where is sine negative? Well, sine is negative here and here. So I know that the angle using pi over 6 could be this angle here, which would be 7 pi over 6, or this angle here, which would be 11 pi over 6. But that does not fit in our restrictions. Remember, our restrictions for sine inverse, because we want it to be a function, is from negative pi over 2 to pi over 2. So instead of saying 11 pi over 6, I am going to say that that is the same as negative pi over 6. So those are coterminal angles. So I know that the only thing that fits within my domain would be that it is sine of negative pi over 6. And then sine of negative pi over 6, well, we know that that is negative a half. So again, sine and sine inverse, they are inverse operations. They cancel each other out. But again, you always want to pay attention to the domain restrictions. Okay, let's try another one. So in this one here, we're going to do the sine inverse of sine of 7 pi over 6. So let's look at the point on the unit circle, 7 pi over 6. So if I look at that, the point on the unit circle for 7 pi over 6 is going to be, so that's going to be in quadrant number 3, so I know that both my values are negative. So it's going to be 7 pi over 6. Let me just think here. That's negative root 3 over 2 and negative a half. So we want to also keep in mind, we have to pay attention to our domain restrictions, okay, because this is not in the restricted domain, okay? Now, the point on the unit circle 7 pi over 6 for sine is the same as the point on the unit circle for 11 pi over 6. For sine only, I'm talking. But that doesn't fit into our restrictions. So to fit into our restrictions, we're going to call this actually the point negative pi over 6. So that's what I'm going to be working with for my restriction, okay? So the sine of 7 pi over 6 is going to be the same as the sine of negative pi over 6, but that fits into my restriction, okay, into my restriction. So that, both of those values is negative a half. So now I'm doing sine inverse of negative a half. So I have the ratio, I am going backwards to the angle, so I know that that angle is going to be negative pi over 6 to fit within the restrictions. So this is a nice example where I did sine inverse of sine. They don't simply cancel out just to be 7 pi over 6. We have to fit them into the domain restriction. Now, you could say that that was 7 pi over 6 and then fit it into our restricted domain, because 7 pi over 6 is the same angle as negative pi over 6. So just remember that your solutions have to lie in quadrant 1 and quadrant 4 only. So when we do sine inverse of sine of x, it cancels out to be x, provided our domain restriction of negative pi over 2 and pi over 2 stay in place. So sine of an angle is a ratio, sine inverse of a ratio is an angle. Conversely, if we're doing sine of sine inverse of x, those also canceled out to be x, but remember the ratio had to be between negative 1 and 1. So sine inverse of x is going to give me an angle, and then sine of that angle will give me a ratio. So that is inverse trig functions for sine. Look to the next video for cosine.